In an unprecedented deep survey of small, faint objects in the Orion Nebula, astronomers using NASA's Hubble Space Telescope have uncovered the largest known population of brown dwarfs sprinkled among newborn stars. Looking in the vicinity of the survey stars, researchers not only found several very low-mass brown dwarf companions, but also 3 giant planets. They even found an example of binary planets, where 2 planets orbit each other in the absence of a parent star. What exactly are these brown dwarfs, and why space scientists are considering this discovery by the Hubble one of its major achievements? Let's find out in this video. Brown dwarfs are a strange class of celestial objects that have masses so low that their cores never became hot enough to sustain nuclear fusion, which powers stars. Instead, brown dwarfs cool and fade as they age. Despite their low mass, brown dwarfs provide important clues to understanding how stars and planets form and may be among the most common objects in our Milky Way galaxy. Located 1,350 light-years away, the Orion Nebula is a relatively nearby laboratory for studying the star formation process across a wide range, from opulent giant stars to diminutive red dwarf stars and elusive faint brown dwarfs. This survey could only be done with Hubble's exceptional resolution and infrared sensitivity. Because brown dwarfs are colder than stars, astronomers use Hubble to identify them by the presence of water in their atmosphere. These are so cold that water vapors form, explain team leads Masita Roberto of the Space Telescope Institute in Baltimore, Maryland. Water is a signature of substellar objects. It's an amazing and very clever mark. As the masses get smaller, the stars become redder and fainter, and you need to view them in the infrared. And in infrared light, the most prominent feature is water. But hot water vapor in the atmosphere of brown dwarfs cannot be easily seen from Earth's surface due to the absorbing effect of water vapor in our atmosphere. Fortunately, Hubble is up and above the atmosphere and has near-infrared vision that can easily spot water on distant worlds. Later in the video, we'll also be revealing the stunning images of the Orion Nebula captured by James Webb. So make sure you stay with us right till the end. The Hubble team identified 1,200 candidate reddish stars. They found that stars split into 2 distinct populations, those with water and those without. The bright ones with water were confirmed to be faint red dwarfs. The multitude of fainter, water-rich, free-flowing brown dwarfs and planets within the Orion Nebula are all new discoveries. Many stars without water were also detected, and these are background stars in the Milky Way. Their light was reddened by passing through interstellar dust, and therefore not relevant to the team's study. The team also looked for fainter binary companions of these 1,200 reddish stars. Because they are so close to the primary star, these companions are nearly impossible to discover using standard observing methods. But by using a unique, high-contrast imaging technique developed by Laurent Pueyo at the Space Telescope Science Institute, astronomers could resolve faint images of a large number of candidate companions. The first analysis did not allow Hubble astronomers to determine whether these objects orbit the brighter star or if their proximity to the Hubble image is a result of chance alignment. As a consequence, they are classified as candidates for now. However, the presence of water in their atmosphere indicates that most of them cannot be misaligned stars in the galactic background, and thus must be brown dwarfs or exoplanet companions. In all, the team found 17 candidate brown dwarf companions to red dwarf stars, 1 brown dwarf pair, and 1 brown dwarf with a planetary companion. The study also identified 3 potential planetary mass companions, 1 associated with red dwarf, 1 with a brown dwarf, and 1 with another planet. We experimented with a method, high-contrast imaging post-processing, that astronomers have been relying on for years. We usually use it to look for very faint planets in the close vicinity of nearby stars, by painstakingly observing them one by one, said Pueyo. This time around, we decided to combine our algorithms with the ultra-stability of Hubble to inspect the vicinity of hundreds of very young stars in every single exposure obtained by the Orion survey. It turns out that even if we do not reach the deepest sensitivity for a single star, the sheer volume of our sample allowed us to obtain an unprecedented statistical snapshot of young exoplanets and brown dwarf companions in Orion. Combining the 2 unique techniques, imaging in the water filters and high-contrast image processing, The survey provided an unbiased sample of newly formed low-mass sources, both dispersed in the field and companions of other low-mass objects. We could reprocess the entire Hubble archive and try to find jewels there, Roberto said. James Webb captures stunning images of Orion Nebula. The James Webb Space Telescope, Webb, has captured the most detailed and sharpest images ever taken of the inner region of the Orion Nebula, a stellar nursery situated in the constellation Orion 1,350 light-years away from Earth. The new images released today were triggered by an international collaboration, which includes researchers from Western University. We are blown away by the breathtaking images of the Orion Nebula. We started this project in 2017, so we have been waiting more than 5 years to get this data. Massive young stars emit large quantities of ultraviolet radiation directly into the native cloud that still hangs around them, and this changes the physical shape of the cloud as well as the chemical makeup. How precisely this works and how it affects future star and planet formation is not yet well known, said Western astrophysicist Els Peters. We see several dense filaments. These filamentary structures may promote a new generation of stars in the deeper regions of the cloud of dust and gas. Stellar systems already in formation show up as well, said Bernet. Inside its cocoon, young stars with a disk of dust and gas in which planets form are observed in the nebula. Small cavities being dug by new stars being blown by the intense radiation of stellar winds of newborn stars are also clearly visible. Proplyds consist of a central protostar surrounded by a disk of dust and gas in which planets form. Several protostellar jets, overflows, and nascent stars embedded in dust are scattered throughout the images. We have never been able to see the intricate fine details of how interstellar matter is structured in these environments and to figure out how these planetary systems can form in the presence of this harsh radiation. These images reveal the heritage of the interstellar medium in planetary systems, says Hobart. Analog evolution. Long considered an environment similar to the cradle of the solar system, scientists today are interested in observing the Orion Nebula to understand, by analogy, what happened during the first million years of our planetary evolution. The hearts of stellar nurseries like the Orion Nebula are obscured by large amounts of stardust, making it impossible to study what is happening inside of them in visible light with telescopes like the Hubble Space Telescope. Webb detects the infrared light of the cosmos, which allows observers to see through these layers of dust, while revealing the action happening deep inside the nebula. Observing the Orion Nebula was a challenge because it is very bright for Webb's unprecedented sensitive instruments. But Webb is incredible. Webb can observe distant and faint galaxies, Jupiter and Orion, which are some of the brightest sources in the infrared sky, said Bernet. At the heart of the Orion Nebula is the trapezium cluster of young massive stars, whose intense ultraviolet radiation shapes the cloud of dust and gas. Understanding how this intense radiation impacts their surroundings is a key question in understanding the formation of stellar systems like our own solar system. Seeing these first images of the Orion Nebula is just the beginning. The PDRS for All team is working hard to analyze the Orion data, and we expect new discoveries of the early phases of these formations of stellar systems, said Hobart. We are excited to be part of Webb's journey of discoveries. That's it for this episode. Hope you've enjoyed watching these fascinating discoveries made by NASA's capable space telescopes. For more similar content, make sure you subscribe to our channel and also press the notification bell. See you at the next one.